Okay, hi. So this video will be going over Physics 2211 Test 2, Problem 2, Olympic sport curling problem, or basically a mass collides with another mass and causes it to go in a certain direction given by this angle. So we know that the initial velocity is 3 meters per second of mass 1, and mass 2, we know that it is initially stationary, and then its final velocity is 2 meters per second. So basically what we need to find is what the final velocity of the mass 1 is after colliding with mass 2, which is relatively simple with conservation of momentum, which is a vector equation, which is very important. First, we have to figure out what the final velocity of 2 is in accordance to the angle at which it is moving. So basically, we have to take final velocity of 2 and use directional cosines to figure out what this is. And basically what that is just to find the angle from the axes at which you're interested in, and then take the cosine of that to find the direction, the velocity at which you're traveling at for the x, y, and z components. In this case, the z component is just 0 because there is no movement in this direction. Okay, so plugging into the conservation of momentum equation, final momentum is equal to initial momentum. We find if we add the initial momentum of 1 with the initial momentum of 2, we find that is equal to the final momentum of 1 and final momentum of 2. Final momentum of 1 was what we're trying to find. This is 0 because it is stationary, and momentum is mass times velocity, and velocity is equal to 0 initially for mass 2. And basically we get the equation P initial with some algebra. P initial is minus P final of 2 is equal to P final of 1. And then then we just basically plug in the different velocities, and we find the final velocity of 1 is 1.714, negative 1.5320 meters per second. From here, simply just find the velocity, or the magnitude of the velocity originally, and give what the question was looking for. 2.299 meters per second. Okay. Part B of problem 1 was simply calculating the contact force, given delta T is 1.5 times 10 to the negative third. So we know the change of momentum is equal to change in momentum over change in time is equal to force, and P final minus P initial divided by delta T equals the force, net force. So this is pretty easy. All you have to do is take the final momentum minus the initial momentum of any of the stones divided by the change in time of the contact, and then we will have the net force. So from here, we just take P final minus P initial, use stone 2. In this case, I use stone 2 because it was easier, because P initial is 0 kilograms meters per second, so delta P is just simply the final momentum. So plugging it in, delta change in momentum over change in time, plug in the values, divide, and then you get the net force is equal to 2.667 times 10 to the 4th.